Find the exact value of each expression. No decimal answers accepted. In part A, we got sine 20 degrees minus cosine 70 degrees. 20 and 70, these angles are not standard angles. So we cannot write down the exact value of sine 20, cosine 70 separately. But there is a relationship between 20 and 70. Okay, 20 and 70, sum of these two angles is 90. That means 20 and 70 are complementary angles, and we know that cofunctions of complementary angles are same. So sine of some angle alpha is same as cosine of complementary of alpha is 90 minus alpha. Okay, if we take alpha equals 20, so sine 20 is same as cosine 90 minus 20, 70. Okay, sine 20 is same as cosine 70. So we can rewrite sine 20 as cosine of 70. Okay, minus cosine of 70. So we don't need to know what the value of cosine 70, but cosine 70 minus cosine 70, that's 0. Okay, next we have secant square 60 degrees minus tangent square 45 degrees. 60 degrees and 45 degrees are standard angles. Okay, and we can find the values, exact values, using right triangles. So 60 degrees, we use the following triangle. Here is the 60 degree, and we know this is 1 root 3 2. So secant 60, secant is this hypotenuse divided by adjacent, 2 over 1. Secant is 2 over 1, and we have a square, so 2 over 1 is just 2 squared, which is 4, by the way, or let's say 2 squared, minus 45 degrees. For 45 we use the following right triangle. Here is a 45. This is 1 1 root 2, and tangent is this b over a, 1 over 1. So tangent 45 is 1 1 square is just 1. 4 minus 1 3. Okay, part C, secant pi over 4. Pi over 4 is same as 45 degrees. Pi over 4 is same as pi over 4. If we want to change this into degree measures, we multiply by 180 over pi, cancel, so we get just 45. So we can use this triangle for secant pi over 4. Secant is root 2 over 1. So secant pi over 4 is root 2 over 1, just root 2, plus 2 times cosecant pi over 3. Pi over 3 is same as 60 degrees, so we can use this triangle. And cosecant is 2 over root 3. Sine would be root 3 over 2. Cosecant is reciprocal of sine, so 2 over root 3 times 2 over root 3. Let's combine these two fractions. Root 2, don't go for decimal, just root 2, plus 4 times 2 times 2, 4 over root 3. Now we can combine these two fractions, but we can't do that much. We can leave here like this. This is the exact value anyway, root 2 plus 4 over root 3. Or you can rationalize this fraction, multiply by root 3 over root 3. Okay, you may leave here, or let's go further. Root 2 plus this would be 4 root 3 over root 3 times root 3 is just 3. Okay, final.